and welcome to the Down the Spirituality and Science Rabbit Hole podcast, number 11, The Cosmos, Mechanism or Organism. Contemporary science is based on the claim that all reality is material or physical. There is no reality but material reality. Consciousness is a byproduct of the physical activity of the brain. Matter is unconscious. Evolution is random and purposeless. God exists only as an idea in human minds and hence in human heads. Here is a belief that most scientists take for granted. Indeed, it's virtually a creed. Everything is essentially mechanical. Dogs, for example, are complex mechanisms rather than living organisms with goals of their own. Even people are machines. Lumbering robots, in Richard Dawkins' vivid phrase, with brains that are like genetically programmed computers. For more than 200 years, materialists have promised that science will eventually explain everything in terms of physics and chemistry. This is promissory materialism because it depends on issuing promissory notes for discoveries not yet made. Rather, it is not anti-scientific to question established beliefs, but central to the beliefs of science itself. At the creative heart of science is a spirit of open-minded inquiry. Ideally, science is a process, not a position or a belief system. Organisms are self-organizing, hence the name. They form and maintain themselves and have their own ends and goals. Machines, by contrast, are designed by an external mind. Their parts are put together by external machine makers, and they have no purpose or ends of their own. In the picture here, you see a machine at the top and an organism at the bottom. Genetic analysis of tardigrades, which is the little organism that you see here, genetic analysis of tardigrades has revealed some of the secrets of their incredible survival abilities. These tiny creatures, sometimes called water bears, can survive radiation, freezing, extreme dehydration, and even the vacuum of space. The starting point for modern science was the rejection of the older, organic view of the universe. The prestige of mechanistic science did not come primarily from its philosophical underpinnings, but from its practical successes, especially in physics. Mathematical modeling typically involves extreme abstraction and simplification, which is easiest to realize with man-made machines or objects. Mathematical mechanics is impressively useful in dealing with relatively simple problems, such as the trajectories of cannonballs or the flight of rockets. One excellent example is billiard ball physics, which gives a clear account of impacts and collisions of idealized billiard balls in a frictionless environment. Not only is the mathematics simplified, but the billiard balls themselves are a very simplified system. However, in the real world, billiard balls collide and bounce off each other in games, but the rules of the game and the skills and motives of the players are outside the scope of physics. The mathematical analysis of the ball's behavior is an extreme abstraction. And here is a major problem. Most of our experience is not mathematical. We taste food. We feel angry. We enjoy the beauty of flowers. We laugh at jokes. In order to assert the primacy of mathematics, Galileo and his successors had to distinguish between what they called primary qualities, which could be described mathematically, such as motion, size, and weight, and secondary qualities, like color and smell, which are subjective. René Descartes, who lived in the 1600s, was the principal proponent of the mechanical or mechanistic philosophy of nature. It first came to him in a vision. Apparently, philosophers are allowed to have visions, but scientists are not. Anyway, it came to him in a vision on November 10th, 1619, when he was filled with enthusiasm and discovered the foundations of a marvelous science. Descartes took the mechanical metaphor much further than Kepler or Galileo by extending it into the realm of life. He also laid the foundations of mechanistic biology and medicine that are still considered orthodox today. Descartes held that animals were in fact just elaborate machines, and it was only our non-mechanical, non-physical minds that made human beings human, and only human beings, intelligent and conscious. We are so used to the machine theory of life that it is hard to appreciate what a radical break Descartes made. The prevailing theories of his time took for granted that living organisms were organisms, animate beings with their own souls. Souls gave organisms their purpose and powers of self-organization. Before the mechanistic revolution, there were three levels of explanation: bodies, souls, and spirits. Bodies and souls were part of nature. Spirits were non-material but interacted with embodied beings through their souls. The human spirit, or rational soul, according to Christian theology, was potentially open to interaction with the Spirit of God. After the mechanistic revolution, there were only two levels of explanation: bodies and spirits. Three layers were reduced to two by removing souls from nature, leaving only the human rational soul or spirit. The elimination of souls also separated humanity from all other animals, which became inanimate machines. The rational soul of man was like an immaterial ghost in the machinery of the human body. The final step in the mechanistic revolution was to reduce two levels of explanation to one. Instead of a duality of matter and mind, there is only matter. This is the doctrine of materialism, which came to dominate scientific thinking in the second half of the 19th century. Nevertheless, despite their nominal materialism, most scientists remain dualists and continue to use dualistic metaphors. It seems impossible to be a consistent materialist. Materialism depends on a lingering dualism, more or less thinly veiled. Machines only make sense if they have designers. Robert Boyle, for example, saw the mechanical order of nature as evidence for God's design. And Isaac Newton conceived of God in his own image as, and I quote, very well skilled in mechanics and geometry. The better the world machine functioned, the less necessary was God's ongoing activity. By the end of the 18th century, the celestial machinery was thought to work perfectly without any need for divine intervention. For many scientifically minded intellectuals, Christianity gave way to deism. A supreme being designed the world machine, created it, set it in motion, and left it to run automatically. Now, this kind of God did not intervene in the world, and there was no point in praying to him. In fact, there was no point in any religious practice. Several Enlightenment philosophers, such as Voltaire, combined deism with a rejection of the Christian religion. Ironically, the belief in the divine design of plants and animals is not a traditional part of Christianity. It stems from 17th century science. It contradicts the biblical picture of the creation of life in the first chapter of the book of Genesis. Animals and plants were not portrayed as machines, but as self-reproducing organisms that arose from the earth and the seas, as in Genesis chapter 1, verse 11. I quote, "And God said, let the earth bring forth grass, the herb yielding seed, and the fruit trees yielding fruit after his kind, whose seed is in itself." Also, in Genesis chapter 1, verse 24, God said, Let the earth bring forth the living creature after his kind, cattle and creeping thing and beast of the earth after his kind." Unquote. In theological language, these were acts of immediate creation. God did not design or create these plants and animals. A central feature of Romanticism was the rejection of mechanical metaphors and their replacement with imagery of nature as alive, organic, and in the process of gestation or development. In other words, the pregnant universe. Charles Darwin and Alfred Russel Wallace's theory of evolution by natural selection attempted to demystify evolution. Natural selection was blind and impersonal and required no divine agency. It weeded out organisms that were not fit to survive and favored those that were better adapted. The source of creativity was within animals and plants themselves. They varied spontaneously and adapted to new circumstances. Darwin gave no explanation for this creative power. In effect, he rejected the designing God of mechanistic theology and attributed all creativity to nature, just as his grandfather had done. Materialism is like an unconscious cult of the Great Mother. The word matter itself comes from the same root as mother in Latin. The equivalent words are materia and mater. The mother archetype takes many forms, as in Mother Nature, or ecology, or even the economy, which feeds and sustains us on the basis of supply and demand. The Greek root echo in both of these words means family or households. In addition, archetypes are more powerful when they are unconscious because they cannot be examined and discussed. The theory of evolution destroyed the argument for mechanical design. A creator God could not have designed the machinery of animals and plants in the beginning if they evolved progressively through spontaneous variation and natural selection. Living organisms, unlike machines, are themselves creative. Let's be clear. No machine starts from small beginnings, grows, forms new structures within itself, and then reproduces itself. Yet plants and animals do this all the time. They can also regenerate after damage and heal themselves. To see them as machines propelled only by ordinary physics and chemistry is an act of faith. To insist that they are machines despite all appearances is dogmatic. Within science itself, the machine theory of life was challenged continually throughout the 18th and 19th centuries by an alternative school of biology called vitalism. Vitalists thought that organisms were more than machines. They were truly vital or alive. In many ways, vitalism was a survival of the older worldview that living organisms were organized by souls. Vitalism was also in harmony with a romantic vision of living nature. However, Francis Crick, who shared in a Nobel Prize for the discovery of the structure of DNA, made this agenda very explicit in his book on molecules and men. He denounced vitalism and affirmed his belief that the ultimate aim of the modern movement in biology is in fact to explain all biology in terms of physics and chemistry. The mechanistic approach is essentially reductionist. It tries to explain wholes in terms of their parts. When nuclei are split up in particle accelerators, like the Large Hadron Collider at CERN near Geneva, a host of further particles appears. Hundreds have been identified so far, and some physicists expect that with even larger particle accelerators, yet more will be found. The bottom has dropped out of the atom, and a zoo of evanescent particles seems unlikely to explain the shape of an orchid flower, or the leaping of a salmon, or the flight of a flock of starlings. Reductionism no longer offers a solid atomic basis for the explanation of everything else. Attempting to explain organisms in terms of their chemical constituents is rather like trying to understand a computer by grinding it up and analyzing its component elements such as copper, germanium, and silicon. One form of molecular vitalism is to treat the genes as purposeful entities with goals and powers that go far beyond those of a mere chemical like DNA. The genes become a molecular intellect. In his book, The Selfish Gene, Richard Dawkins endowed them with life and intelligence. Living molecules rather than God are the designers of the machinery of life. In Dawkins's words, DNA moves in mysterious ways. The DNA molecules are not only intelligent, they also are selfish, ruthless, and competitive, like successful Chicago gangsters. The selfish gene creates form, molds matter, and engages in an evolutionary arms race. They even aspire to immortality. The persuasive power of Dawkins's rhetoric depended on anthropomorphic language and his cartoon-like imagery. He admits that his selfish gene imagery is more like science fiction than science, but he justifies it as a powerful and illuminating metaphor. The most popular use of a vitalistic metaphor in the name of mechanism is the genetic program. Genetic programs are explicitly analogous to computer programs, which are intelligently designed by human minds to achieve a particular purpose. Programs are purposeful, intelligent, and goal-directed. If challenged, most biologists will admit that genes merely specify the sequence of amino acids in proteins, or are involved in the control of protein synthesis. They are not really programs. They are not selfish. They do not mold matter or shape form or aspire to immortality. A gene is not for a characteristic like a fish fin or the nest-building behavior of the weaver bird. To be very clear, as the picture here says, genes only make proteins. Here, this picture depicts the nucleus with the DNA coming out of it that is then transcribed into RNA. The RNA goes to the ribosome, which is pictured in the center of the diagram. The ribosome is the organelle where proteins are made. You see the RNA is going through the rhizome. Below it, you see little messenger RNAs carrying individual amino acids. They then combine in the ribosomes, and the amino acids are placed in a sequence specified by the messenger RNA to build the protein that you see in the lower right-hand corner. So as such, DNA is only a blueprint for the manufacture of various proteins. That's all that it does. It doesn't tell anything how to be put together, such as the blueprint for a house or a machine part, where you can see how the blueprint tells you where the things belong and how they fit together. DNA only does that for proteins. It doesn't tell the proteins what to do, how to combine in cells, how to interact in cells. It is, again, only a blueprint for the manufacture of proteins. Whereas the mechanistic and vitalist theories both date back to the 17th century, the philosophy of organism, also called the holistic or organistic approach, has been developed only since the 1920s. One of its proponents was the philosopher Alfred North Whitehead. Another was Jan Smuts, a South American statesman and scholar. The philosophy of organism, in effect, treats all nature as alive. In this respect, it is an updated version of pre-mechanistic animalism. Even atoms, molecules, and crystals are organisms. As Smuts puts it, both matter and life consist in the atom and the cell. of unit structures whose ordered grouping produces the natural wholes which we call bodies and organisms. Atoms are not inert particles of stuff, as in old-style atomism. Rather, as revealed by 20th century physics, they are structures of activity, patterns of energetic vibration within fields. In Whitehead's words, I quote, "Biology is the study of the larger organisms, whereas physics is the study of the smaller organisms." In the light of modern cosmologists, physics is also the study of very large organisms like planets, solar systems, galaxy, and the entire universe. The philosophy of organism points out that everywhere we look in nature, at whatever level or scale, we find wholes that are made up of parts that are themselves wholes at a lower level. These organized systems are all nested hierarchies. At each level, the whole includes the parts. They are literally within it. And at each level, the whole is more than the sum of its parts, with properties that cannot be predicted of from the study of the parts in isolation. For example, the structure and meaning of this sentence could not be worked out by a chemical analysis of the paper and the ink, or deduced from the quantities of letters that make it up. For example, there are 5 AS's, 1 B, 5 CS's, 2 DS's. Knowing the numbers of constituent parts is not enough. The structure of the whole depends on the way they are combined together into words and on the relationship between the words. Arthur Koestler proposed the term holon for wholes that are made up of parts that are themselves wholes. In the course of evolution, new holons arise that did not exist before. For example, the first amino acid molecules, the first living cells, or the first flowers, or the first termite colonies. Since holons are wholes, they must arise in sudden jumps, which is exactly what happens in the evolution of living things. Until the 1960s, most scientists still thought of the universe as a machine, and moreover as a machine that was running out of steam, heading to the thermodynamic final heat death. It was not until 1927 that Georges Lemaitre, a cosmologist and Roman Catholic priest, advanced a scientific hypothesis similar to Hume's idea of the origin of the universe in an egg or seed. Lemaitre suggested that the universe began with a creation-like event, which he described as the cosmic egg exploding at the moment of creation. Later called the Big Bang, this new cosmology echoed many of the archaic stories of origins like the Orphic creation myth of the cosmic egg in ancient Greece, or the Indian myth of Hiranyagarbha, the primal golden egg. Sorry, I'm sure I mangled that Indian name. However, cosmology now tells a story of a universe that began extremely small, less than the size of a pinhead, and also it was very hot. It has been expanding ever since. As it grows, it cools down, and as it cools, new forms and structures appear within it. Atomic nuclei and electrons, stars, galaxies, planets, molecules, crystals, and biological life. The machine metaphor has long outlived its usefulness and holds back scientific thinking in physics, biology, and medicine. Our growing, evolving universe is much more like an organism, and so is the earth, and so are oak trees, and so are dogs, and so are we. Can you really think of yourself as a genetically programmed machine in a mechanical universe? Probably not. Probably even the most committed materialists can't either. Most of us feel we are truly alive in a living world, at least on the weekends. But through loyalty to the mechanistic worldview, mechanistic thinking takes over during working hours. But instead of dismissing our own observations and insights to conform to mechanistic dogma, we can pay attention to them and try to learn from them. The recognition of the Earth as a living organism is a major step towards recognizing the wider life of the cosmos. If the Earth is a living organism, what about the Sun and the solar system as a whole? If the solar system is a kind of organism, what about the galaxy? Cosmology already portrays the entire universe as a kind of growing superorganism born through the hatching of the cosmic egg. These differences in viewpoint do not immediately suggest a new range of technological products, and in that sense they may not be economically useful. But they make a big difference in healing the split created by the mechanistic theory, a split between our personal experience of nature and the mechanical explanation that science gives us. And they help heal the split between the sciences and all traditional and indigenous cultures, none of which sees humans and animals as machines in a mechanical world. In conclusion, the mechanistic theory is based on the metaphor of the machine, but it's only a metaphor. Living organisms provide better metaphors for organized systems at all levels of complexity, including molecules, plants, and societies of animals, all of which are organized in a series of inclusive levels in which the whole at each level is more than the sum of the parts, which are themselves wholes at a lower level. Even the most ardent defenders of the mechanistic theory smuggle purposive organizing principles into living organisms in the form of selfic genes or genetic programs.